Humans will need power to be able to survive on Mars. Mars does not have the atmosphere required for us to breathe safely, nor does it have the temperatures that can keep a human safely warm. In addition, power will be needed to manufacture the fuel for the return journey home. Today I'd like to talk to you about the power needs for a spacecraft or base on Mars. My name is Ben Pearson, and I am the Roadster Tracker. The International Space Station is capable of supplying up to 120 kilowatts of power from its solar panels. More typically, it provides about 80 kilowatts of available power. These solar panels weigh an estimated 60 metric tons. The International Space Station can support 6 astronauts for a long period of time and can support as many as 9 given the necessity. When the International Space Station could first be habited, it only had about 6 kilowatts of power, which was barely sufficient to power the 2 modules that were connected to it at the time for 3 astronauts. Time allowed the International Space Station to be upgraded to what you see today. During those early days, they could not maintain life support as easily as they can now. Robert Zubrin's The Case for Mars allocates about 100 kilowatts of power in order to keep the 4 astronauts alive. This also includes the necessity to refuel the spacecraft. Solar power is the most commonly type of power used to support people or satellites in space. It is the only form of power that can be sustained for a lengthy period of time that is safe enough currently to operate around humans. Solar power's efficiency would be reduced on the surface of Mars due to having less solar power that far away from the sun. It would take about 40% more solar panels in order to supply a Mars base compared to that of Earth. Fundamentally, there are 2 types of solar power that could be used: photovoltaics and mirror-based systems. Fundamentally, there are 2 types of power which might be used: photovoltaics and mirror-based systems. Photovoltaics are what are used at the International Space Station and virtually every other spacecraft that has been ever launched into space. These are the type of solar panels that you might put on top of your roof. They require advanced electronics manufacturing capabilities in order to manufacture them. However, they are the most efficient form for most purposes. This is by far the most commonly used type of solar power in existence today. An alternative form that is somewhat more appealing for use on Mars is the use of some kind of a reflected system. This particular system works much like a telescope, focusing all of the light from the sun onto the object in the center, which is then heated and used to produce electricity. This power can be stored quite easily for use at a future time and does not require the use of batteries. This system is not commonly used on Earth because it requires clear visibility to the sun. Any clouds in the sky might reduce the efficacy of this system and not allow it to produce any power at all. On the surface of Mars, most of the time there is no clouds. Thus, this seems like an appealing system for the majority of the power, and it could be much more easily manufactured than photovoltaics. The biggest risk in using solar power is giant windstorms that sometimes cover the entire surface of Mars. You can see Mars as it is visible when there is no wind on the left. On the right is when there is a global dust storm covering the entire planet. In July 2018, one such storm has covered the entire surface of the planet of Mars, and as of recording, the Opportunity rover has lost contact with Earth for a period of approximately 1 month due to this storm and its reliance only on solar power. The Great Dust Storm of 2018 reduced Opportunity's power to approximately 1% of that which would be available had there been no dust storm present. A more robust form of power was used by the Curiosity rover, which you can see circled on the back of this vehicle. This is a radioactive thermal generator, an RTG, and is a form of nuclear power. It does not rely on any visibility to the sun, and thus Curiosity has been unhampered by the global dust storm circling the red planet. This RTG used by Curiosity can only produce 110 watts of electricity. However, it is capable of producing much more thermal power at approximately 2 kilowatts. In the bookend movie, The Martian, Mark Watney made use of the heat of an RTG in order to survive the cold Martian nights without any solar power. An RTG, however, is a very inefficient system when it comes to the creation of power. There have been far more efficient systems which have been sent into space already that utilize nuclear power. The use of nuclear reactors in space has been limited in order to prevent any damage to Earth should a rocket explode which is carrying a nuclear reactor. You can see two examples of reactors here. The one on the left is a SNAP reactor prototype that was manufactured by the United States and produces about 500 watts of power, but far, far more heat in the realm of about 30,000 kilowatts. On the right, you can see a scaled-down model of the Topaz Reactor, which was flown in 1987 by the Soviet Union. Early versions of this reactor leaked radioactive coolant in orbit and forced an early end to the program. The Topaz Reactor was capable of supplying up to 10 kilowatts of power. A larger version of this was made, known as the TOPAZ-II. The United States even purchased some of these from the post-Cold War Russia in order for consideration for use in space. However, they were never actually launched into space. This upgraded design would be able to provide 40 kilowatts of power. That is almost a third of the power that is available to the International Space Station. Currently, the United States is developing a safe and effective nuclear reactor for the use in space. This project is known as the Kilopower Project, and it is based off of a Stirling nuclear reactor. It can produce up to 10 kilowatts of power. Models of this have been tested on the ground and could be used in future Moon and Mars bases as well as missions to the outer planets. The largest designed reactor that I have ever heard of for use in space was the reactor that was planned for the Jupiter Icy Moons Orbiter JIMO, which had an astounding power of 200 kilowatts. This project was canceled fairly early on in the process, as the cost overruns were expected to be immense, but had this spacecraft been able to make it to Jupiter, it would have been able to thoroughly explore all of the moons of Jupiter. This spacecraft would have more than sufficient power to power the entire Martian base. The last form of power that we want to consider for use on Mars is the wind power. Air is much thinner on Mars, approximately 1% of the atmospheric pressure of that on the sea level. However, the air is composed of carbon dioxide, as compared to the nitrogen and oxygen, which are much lighter, that is found on the surface of the Earth. Thus, there is only about a 2% efficiency difference. That still seems low, but wind speeds on Mars are much, much higher on average than they are on Earth. As wind power increases with the square of the wind velocity, a factor of 2 to 3 times more power in wind will enable it to be 4 to 9 times as powerful as that of an equivalent condition on Earth. Thus, while wind power is much more inefficient as compared to on Earth, it still would be able to provide some power on the surface of Mars without the presence of sunlight. The wind on Mars, much as it is on Earth, is not always continual. Thus, we would have to have batteries and other forms of redundant technology. However, this could prove a useful form of backup in the event of a global dust storm. One other advantage of wind power is that it could be easily manufactured on the surface of Mars. The wind power is sufficient that a small drone will be included with the upcoming Mars 2020 rover. In summary, nuclear, wind, and solar power all might be useful on the surface of Mars. Wind and solar could potentially be manufactured on the planet, which would allow us to expand the base beyond what the materials can be sent from Earth. A combination of these three powers, no doubt, will enable us to provide power to astronauts at all times. Thank you very much for joining me. Let me know whatever questions or comments you guys have about this or anything else Mars related. Thank you for joining me, and until next time, keep on tracking. Take care.